Hello everyone, my name is Andrew Becker, and as you can see from my timestamp here, it is June 23rd, 2022. And today in this video, I'm going to be going over a little bit of the iterative process using the logistics map. And then we're going to do a Delta-Epsilon proof on the limit that we get from that iterative process. So let's get started. So here's our problem. Here's the function for our logistics map. F of x equals r, constant, times x, times 1 minus x. For our purposes, we are going to set r equal to 1.5 and use an initial value of 0.2. This will be more important later on when we're actually doing the work on this, but 1.5 equals 3.2. So we can just plop that in place of 1.5. All right, let's do our iterations. So we are going to start with 0.2, plug that into our function, right? And very quickly, we see that the numbers start to converge. And they converge on 0.33333 repeating, or x equals 1/3. Now, it kind of necessarily follows that if x is approaching 1/3 equals 1/3, well, that sounds an awful lot like a limit. So we can say that the limit as x approaches 1/3 of our function 3 over 2x times 1 minus x equals 1/3. It seems pretty self-evident. This is math, however, and we don't take things as being self-evident, we prove them. So let's do that. We're going to use our Delta-Epsilon proof to prove that this limit exists. All right, so here's our limit. Remember, for Delta-Epsilon proofs, epsilon is going to be the distance away from our target value on the y-axis. That's going to be the absolute value of the function, right, minus the limit of 1/3 is less than epsilon. And then for that, we are going to have a delta that is the absolute value of x minus what x is approaching. Right, so let's plug our stuff in for that general equation. We have the absolute value of 3 over 2x times 1 minus x minus 1/3 is less than epsilon, and the absolute value of x minus 1/3 is less than delta. Now, in order to proceed with our proof, we need to establish an equivalency between epsilon and delta. Basically, figure out which magnitude brings those two values together. And to do that, we're going to algebraically manipulate this expression so that it contains this expression, right? So let's start. First, we'll move 3 over 2x into 1 minus x. That gives us negative 3 over 2x squared plus 3 over 2x minus 1/3. From that, we'll factor out negative 3 over 2. And we're left with negative 3 over 2 times x squared minus x plus 2/9. We need to split this polynomial into two expressions. I'll save you the work. I already did it. It is negative 3 over 2 times x minus 1/3 times x minus 2/3. And we can double check that just to make sure. We have x times x is x squared. Negative 1/3 times negative 2/3 is positive 2/9. Excuse me. And then x minus negative 1/3 x minus 2/3 x, our inner and our outer, is going to equal negative 1x. So we did a good job factoring there. And as you can see, this expression for delta has already shown up, that x minus 1/3. So definitely made some headway there. We still have a little more work to do. Here's our limit, just so we don't forget. And what we need to do first is to divvy up the absolute value. So we can use the property of absolute values to say that the absolute value of x minus 1/3 times the absolute value of negative 3 over 2 times the absolute value of x minus 2/3 is less than epsilon, is equivalent to that top one. And what we need to do now, right, we're so close, but we need to find something to substitute in for this, because we can't divide both sides by negative 3 over 2 times x minus 2/3. Epsilon can't have another variable over there. So we need to find something to substitute in for this. And to do that, we're going to do something interesting. We're going to set delta equal to some positive number. I chose 1/2. Right? Now, if delta equals 1/2, then it naturally follows that the absolute value of x minus 1/3 is less than 1/2. And we can rewrite this as negative 1/2 is less than x minus 1/3, which is less than 1/2. And from here, we can kind of manipulate this by adding things, or subtracting things, or multiplying things to each piece. So let's start by isolating x by adding 1/3 to each side. That gives us negative 1/6 is less than x, which is less than 5/6. And since we've got x isolated, we are going to build that back into this expression, right? So we start by subtracting 2/3 from each piece. That gives us negative 5/6 is less than x minus 2/3, which is less than 1/6. And then we can multiply everything by the absolute value of negative 3/2, which is 3/2. That gives us negative 5/4, which is less than 3/2 times x minus 2/3, which is less than 1/4. And this end piece, that is what we are interested in, right? Here's our equivalency. So we can take this and substitute 1/4 in for that expression. And that yields 1/4 times the absolute value of x minus 1/3 is less than epsilon. Multiply both sides by 4, and we get the absolute value of x minus 1/3 is less than 4 epsilon. So we can say that our delta equals the smaller value of either 1/2 or 4 epsilon. Because epsilon can be a very, very, very tiny number. Remember, that's just the distance from our target on the y-axis. We're going to use that as our smaller number for the proof. So let's actually do the proof. All right, we're going to prove that the limit as x approaches 1/3 of 3/2x times 1 minus x equals 1/3. We're going to start by saying that epsilon is greater than 0, right? That's how we start all of these proofs. And we're going to choose our delta as the smaller value of either 1/2 or 4e. We already said we're going to be working with 4e. And we are going to assume that 0 is less than the absolute value of x minus 1/3, which is less than delta. So from there it follows that if the absolute value of x minus 1/3 is less than delta, that means that the absolute value of x minus 1/3 is less than 4e, which also follows that 1/4 times the absolute value of x minus 1/3 is less than e. So we're just kind of undoing everything we did in our setup, but that's how the proof works, right? So now what we have to do is we have to figure out how to substitute 1/4 back in for the other piece to the expression. So we know from our setup that if delta equals 1/2, then the expression, the absolute value of 3/2 times the absolute value of x minus 2/3 needs to be less than 1/4, right? And then if we plug 4 epsilon into that, it still follows that this expression is less than 1/4. It actually just means that it's actually less than 1/4 than the original one. The specifics aren't really important. What matters is that the inequality still holds, and we can use that to substitute the absolute value of negative 3/2 times the absolute value of x minus 2/3 back into this expression. So let's do that, right? Let's bring the absolute values to the outside. Dun, 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 dun. Okay, and then we're just basically going to work our way backward. We're going to start by foiling to get negative 3/2 times x squared minus x plus 2/9. Then we are going to distribute the negative 3/2. And finally, we're just going to divide out 3/2x just from this first part of the expression. And there we have our original function, 3/2 times x times 1 minus x minus its limit, 1/3, is in fact less than epsilon. And we can say that the limit of f of x, where x approaches 1/3, does indeed equal 1/3. So, thank you so much for watching, and I'll see you in the next video.